السلام عليكم. انا رجعت لكم تاني زي ما اتفقنا. احنا الوقت عندنا قصير، وزي ما وعدتكم ان شاء الله هنحل كل البيبرز بتاعت المودولار اكزام يونت 1 ويونت 2 عشان الامتحان القريب اللي هو بعد حوالي اسبوع او 10 ايام. طيب احنا النهارده هنعمل ايه؟ النهارده ان شاء الله هنجاوب مع بعض 1 سي ار يونت 1 برضو اللي هو ماي جون فيرست مودولار اكزام يونت 1 زي ما اتفقنا، بس 1 سي ار. طيب يلا بينا نبدأ على طول نجاوب الأسئلة بتاعتنا. First question بيجي طبعا some questions must be answered with cross in a box. قلنا الكلام ده قبل كده. If you change your mind ممكن تحط لاين كده في البوكس وتعمل الكروس في التشويس التاني اللي انت عايز تختاره. First question بيقول لنا ايه؟ بيقول لنا 1A the diagram shows an incomplete periodic table. Use the information from the diagram to answer all parts of this question. First one بيقول لي give symbol of group 1 metal. group 1 metal طبعا انتوا عارفين اكيد ان ده group 1، يبقى group 1 metal هيكون K. next one بيقول لي give the symbol of a noble gas. برضو I'm sure ان انتوا عارفين ان noble gases هم دول، فهيبقى xenon Xe. give the symbol of two elements in the same period. برضو I'm sure ان انتوا عارفين ان ال period from left to right، فاحنا عندنا بريليوم ومعاه اكسجين او سيلفر ومعاه زينون. خلينا نكتب بريليوم عند اكسجين. طب لو حد كتب الاتنين التانيين برضو صح. give the number of electrons in the outermost shell او outer shell of an atom of aluminium. طيب احنا عارفين ان جروب 1 بيبقى عندهم 1، هنا بيبقى عندهم 2، وهنا بيبقى عندهم 3 electrons in the outer shell. فانا هنا هكتب له ايه؟ هكتب له 3 electrons. بعد كده بيقول draw diagram to show configuration electron configuration of aluminium. طيب احنا بيكون عندنا النيوكليس بتاعت الالومنيوم في النص كده، بيكون حواليها الفيرست شيل، السكند شيل، وبعد كده الثيرد شيل. الفيرست شيل هيكون فيه just 2 electrons ادي 1 2. السكند شيل هيكون فيه 8 ادي 1 2 3 4 5 6 7 8. الثيرد شيل هيكون فيه 3 لسه قايلينها من شوية 1 2 3 كده رسمناها. next question بيقول لي هنا a sample of sulfur contains 94% of the isotope sulfur 32 و 6% من isotope sulfur 34. calculate the relative atomic mass of the sample. اوكي بسيط. we just multiply percentage abundance times the mass of each isotope and add them together. 6 multiply 34 divided by 100 and we are talking about percentage. It will give 32.12. طب لو حد كتبها مثلا 32.1 اوكي accepted مفيش مشكلة. 32.1 اوكي 32.12 برضو اوكي، بس ما ينفعش ان احنا نكتبها 32. وكده يبقى جاوبنا question 1. Let's start to solve question 2. This question is about the 3 states of matter: solid, liquid, and gas. Solids, liquids, and gases can be changed from one state to another. The box gives the names of some changes of state: condensing, evaporation, freezing, melting, sublimation. Use words from the box to answer the questions. Give the name of the change from liquid to solid. I'm sure you know that from liquid to solid from the box: freezing. Give the name of a change from liquid to gas. From liquid to gas: evaporation. Give the name of the change from solid to gas. From solid to gas: sublimation. Then he asks you to describe the arrangement, movement, and energy of the particles in a gas. For the arrangement, we can say that particles are far apart and randomly arranged. For the movement, we can say that particles, we can say move randomly, or particles have or move freely. For the energy, we can say that particles have high energy. Particles have high energy. Particles have high energy. That's for question 2. Let's start to solve question 3. Question 3 says that this question is about acids and metal carbonates. Give the formula of the ion found in all aqueous solutions of acids. Hydrogen ion, hydrogen positive 1. You can write hydrogen ion, but he asked about formula. Potassium carbonate is a weak base. Suggest the pH of potassium carbonate solution. You can write 8, 9, 10. I can write 10. But also you can write range from 8 to 10, like this, 8 to 10, or مثلا 8 to 9. You can write it as a range, or you can write one value within a range 8, 9, 10. Okay. Next question, C. Potassium carbonate reacts with hydrochloric acid. Gives the name of the salt formed. Potassium carbonate K2CO3 react with HCl, 2HCl, to give KCl and carbon dioxide and water. He didn't ask about the equation. I just telling you which salt formed. The salt formed, he asks about the name, not the formula. So potassium, you can write potassium from here, chloride. Potassium chloride. Next part, the formula of potassium carbonate is K2CO3. Calculate the relative molecular mass. We want to calculate molecular mass. Let's check for potassium, it's 39, carbon, I'm sure you know carbon 12, and the oxygen 16. 39, 12, 16, okay. So we can write it as 39 multiply 2 plus 12 for carbon plus 3 multiplied 16 for oxygen. This gives 138. So you can write 138 right here. Next one. 4 test tubes, each contain 5 cubic centimeter of water. A different metal carbonate is added to the test tubes. The diagram shows the results. After the metal carbonates have been stirred in the water, explain which test tube A, B, C, or D could contain potassium carbonate. I'm sure you know that potassium carbonate is soluble. Potassium carbonate is soluble salt. So the correct answer is B, because this is the only metal carbonate that has dissolved or soluble. Or we can write that potassium carbonate is a soluble salt. Just telling him that potassium carbonate, I'm sure you know, is soluble salt, and this for question 3. Let's solve question 4. This question is about mixtures. The table shows experimental values for the boiling point temperature ranges of 4 different substances, B, Q, R, and S. Explain which substance B, Q, R, and S is most likely to be pure. Check the temperature range. In this one, 78 and 79, so the difference is only 1. Difference is 5 degrees Celsius. Difference 6 degrees Celsius, and difference 10 degrees Celsius. He asks about the one that most likely to be pure. this one because the difference is very small. So you can write this question by choosing B because B has the smallest range. Next part, describe how pure water can be obtained from a solution of salt and water using simple distillation. First step, salt and water solution is heated. The salt and water solution is heated. Number 2, the water evaporates. Third part, we have to write 4 points. Water vapor is cooled in the condenser. Then pure water is corrected after condensation. This for question 4. Let's try to solve question 5. Question 5 asks about, this question is about rusting. Give the names of 2 substances that react with iron to form rust. I'm sure you know that water and oxygen. Iron can be coated with zinc to prevent rusting. Name this coating process. This coating process is called galvanizing. Or galvanization. Explain how the zinc coating prevents the iron from rusting. Zinc is more reactive than iron. Zinc is more reactive than iron, so zinc is oxidized instead of iron. Next one, iron is in the lower part of the reactivity series. Iron 2 sulfate solution reacts with magnesium metal. State that this type of reaction is called displacement. Give a chemical equation for the reaction between iron 2 sulfate solution and magnesium in crude state sample. Iron 2 sulfate is FeSO4 aqueous. React with magnesium solid to give iron solid plus MgSO4 aqueous. وكده يبقى خلصنا question 5. Let's start to solve question 6. This question is about products from crude oil. Most of the compounds in crude oil are from the same homologous series. Give the name of this homologous series. Alkene. Many fuels are obtained from the fractional distillation of crude oil. Explain how the combustion of a common impurity in fuels causes acid rain. The common impurity هو sulfur. We can say that when sulfur burns, sulfur dioxide اللي هو SO2 forms, which reacts with rainwater. we can say dissolve in rainwater. It's okay. The equation shows the cracking of a hydrocarbon produced from fractional distillation of crude oil, gives the temperature and the catalyst used in catalytic cracking. As you can see, decane converted into octane and ethene. So the temperature used is 600 to 700 degrees Celsius. And the catalyst, we can write zeolite. Also, we can write alumina or even silica. All of this considered as correct. Explain why cracking is a useful process in the oil industry. At the beginning, long-chain alkanes which have lower demand occurs. Cracking produces shorter alkanes that are more useful as fuels. Also, cracking produces alkenes that can be used to make polymers. Let's write this. Long-chain alkenes have lower demand, less useful. Cracking produces shorter alkanes that are more useful as fuels. Also, cracking produces alkenes that can be used to make polymers. Next question, the formula C5H12 represents 3 isomers. Explain what is meant by the term isomers. Isomers compounds have same molecular formula, as you can see, C5H12, but different, we can say structural or disparate formulae, different structural formulae. This is the disparate formula of one of the isomers. As you can see, it's normal bentane. Draw the disparate formula of each of the other 2 isomers. We can write or draw 4 carbons with 1 branch in the second one, or 3 carbons with 2 branches, 1 up and 1 down in the second one. Don't make the branch in terminal carbon because it will increase the length of a chain. So just completing hydrogens, each carbon form 4 bonds like this, 1, 2, 3, and 1, 1, 2, 1, 2, 3, as you can see. The other one, 1, 2, 3, 1, 2, 3, 1, 2, 3, and 1, 2, 3. Just adding hydrogens. Now we solved question 6. Let's solve question 7. A student investigates the reaction between zinc and copper 2 sulfate solution. This is the equation for the reaction zinc solid plus copper sulfate aqueous gives zinc sulfate aqueous plus copper solid. This is the student method. Step 1, add 25 cubic centimeter of copper 2 sulfate solution to a glass beaker. Step 2, record the temperature of the solution. Step 3, add between 5 gram and 6 gram of zinc powder and excess, take care of this part, excess zinc powder, and stir the mixture. Step 4, record the highest temperature reached. First question, AI, explain an improvement to step 1 to produce more accurate temperature rise. He uses glass beaker. We need to thermally insulate the experiment. So the improvement is use a polystyrene cup. Use a polystyrene cup. So less heat will be lost. Next question, give a reason why the student does not need to know the exact mass of zinc added in step 3. As you can see that in step 3, he told us that zinc powder is in excess. So we can write that the zinc is in excess. State the color change in the solution. If you check, we started with copper sulfate, which is blue in color, and converted into zinc sulfate, which is colorless. So the color change will be from blue to colorless. Part BI. The table shows the student results. Volume of copper 2 sulfate is in cubic centimeter 25. Initial temperature of copper 2 sulfate in degrees Celsius 18.5. And final temperature of the copper 2 sulfate in solution is 48.6. To obtain delta T, just subtract this from this. So calculate the heat energy change Q in joules. C is equal 4.2. Mass of solution is the same as volume because density is equal to 1. First step, we have to calculate delta T. Delta T is equal to 48.6 minus 18.5, as you can see. It's equal to 30.1. Then Q equal MC delta T. Let's check mass. We can use volume as mass because volume is equal to mass. 25, we see 4.2, delta T 30.1. So 25 times 4.2 times 30.1 gives 3160.5 joule. So we can write 3160.5. Student repeats the experiment and calculate Q as 3800 joule. The solution used contain 6.38 gram of copper 2 sulfate. Calculate the molar enthalpy change delta H in kilojoule per mole. Include a sign in your answer. Sign will be negative because it's exothermic reaction as temperature rise. At the beginning, we have to calculate number of moles of CuSO4, which is equal to 6.38 divided by 159.5. It will give 0.04. Then we have to calculate delta H. Delta H is equal to 3800 divided by 0.04 Q over N, which equal to 95,000, but we have to convert it into kilojoule to be kilojoule per mole. So divide by 1000, it gives 95 kilojoule. So the answer will be minus 95 kilojoule per mole. As you can see, remember that negative value indicates it's exothermic because the temperature rise. Question 8. This question is about extraction and the uses of metals. Which metal is least reactive? As you can see, lithium is considered extremely reactive. Magnesium is reactive. Zinc is reactive. the least reactive is gold. So the correct answer is A. Copper can be extracted from copper ores. Before copper metal can be extracted, the ore must be dug out of the ground. نخبط كده ندق عليها لحد ما نحفر وناخدها. So just one disadvantage of digging for ores. We can say dust pollution. بتطلع dust. I prefer to say noise pollution. Noise pollution. هنقعد ندق كده ونخبط. في حاجات كتير. We can say destruction of habitat, ecosystem, expensive, time consuming, dust pollution, waste, كل ده. طيب bronze is an alloy of copper and tin. A sample of bronze contains 89% copper atoms and 11% tin atoms. There are 1,200 atoms in this sample. Calculate the number of copper atoms in this sample. Percentage of copper is 98, so we can say 89. 89 divided by 100 multiply 1,200. It will give 1,068. So the answer will be 1,068. Next question. Draw a diagram to show how the atoms of copper and tin are arranged in bronze. Include at least 3 rows of atoms with about 10 atoms in each row. You can draw atoms like this. As you can see, I just drew different size. Tin larger than copper. Tin copper. Explain why the alloy bronze is harder than pure copper. There are atoms of different sizes, so the layers are disrupted and can not slide over each other. This for question 8. Let's start to solve question 9. This question is about the solubility of sodium chloride in water. State the term used for sodium chloride when dissolved in water to form a solution. It's called solute. Next one, describe an experiment to find the maximum mass of sodium chloride that can be dissolved in a known volume of water. First step, add known volume of water to boiling tube. Take care, this question is out of 6. Add an excess sodium chloride to the boiling tube. Sodium chloride must be in excess. Add an excess sodium chloride to the boiling tube. We have to stir. Then measure the temperature of saturated solution. Measure the temperature of saturated solution. Then we have to weigh an empty evaporating basin. Weigh an empty evaporating basin. Then pour some of the saturated solution into the evaporating basin. Pour some of the saturated solution into the evaporating basin. Then wait again. And contents. Heat the evaporating basin to remove all water. We just evaporate water. Then we have to weigh the evaporating basin with the remaining salt, which is sodium chloride. Then subtract to get the mass of sodium chloride that is dissolved. Subtract the mass of basin with salt remaining from the mass of basin with solution. That's it for this question. In the experiment, the mass of sodium chloride obtained was 6.7 gram and the mass of water removed 18.4 gram. Calculate the solubility of sodium chloride in gram per 100 gram of water. 6.7 gram present in 18.4 gram water. So 100 gram water will contain how many grams of sodium chloride? Just 100 multiply 6.7 divided by 18.4, you will find it as 36 gram per 100 gram of water. The solvent used affects solubility. State one other factor that affects solubility: temperature. Next one, in another experiment, 1.42 mole of sodium chloride dissolved in 250 cubic centimeter of water. Calculate the molar concentration of this solution using this expression. We have amount 1.42, we have moles 250. Now you can calculate the molar concentration. Molar concentration will be equal to 1.42 multiplied 1000 divided 250. It will give 5.68 mole per cubic decimeter, so you can write here 5.68. And this for question 9. Now let's start to solve question 10, last question. This question is about vanadium and its reactions. vanadium oxide V2O5 is an oxidizing agent. Explain the term oxidizing agent. Oxidizing agent is a substance that is reduced and gains electrons. Next about vanadium oxide, vanadium 5 oxide or V oxide act as a base when it reacts with nitric acid. Complete the equation to show the balanced reaction. React with nitric acid, so we have to write HNO3 right here. But we have 2 NO3, so you have to multiply by 2 right here. Now we have 2 hydrogen and 1 extra oxygen. Now let's check the number of oxygen. We have 2 multiply 5 equal 10 and 5 right here, and 2 multiply 3 equal 6. 6 plus 5 equal 11. So we have to write water right here to balance oxygen and hydrogen. Vanadium V oxide can be reduced to form a new oxide. The new oxide contains 2.04 gram of vanadium and 1.28 gram of oxygen. Calculate the empirical formula. Vanadium and oxygen 2.04, 1.28 divided by 51 AR of vanadium divided by 16 AR of oxygen, you will get 0.04 and 0.08. So the ratio is 1 to 2 by dividing by the smallest, and the formula will be VO2. So the empirical formula will be VO2. And now we finish the exam. أتمنى إن شاء الله تكونوا استفدتوا من البيبر دي، وانتظروا إن شاء الله شرح كتير جدا هينزل في الفترة الجاية على القناة. اعمل سبسكرايب، اعمل شير للقناة، واستنى فيديوهات كتير، وكمان في فيديوهات كتير هتنزل لشرح كامبريدج OL، وهتنزل حل امتحانات لكامبريدج عشان بيبر 2 اللي قدامها برضه فترة قصيرة، وهينزل كمان ال AS Edexcel. أشوفكم على خير، ولا تنسوني من صالح دعاءكم. السلام عليكم.